Welcome to Ohmsschools.Africa. Please kindly support us by following, subscribing, and liking our videos on YouTube, Facebook, and TikTok. This is why you need to understand IVF laboratories. In vitro fertilization, or IVF, has become synonymous with hope for couples struggling with infertility. This remarkable technology allows for fertilization and early embryo development outside the body, in a controlled laboratory setting. IVF laboratories are specialized facilities at the heart of this process, playing a crucial role in the success of assisted reproductive technology, or RT. These labs are meticulously designed to mimic the physiological conditions of the female reproductive tract, providing the optimal environment for gametes, eggs and sperm, to meet, fertilize, and for embryos to grow. The success of IVF relies heavily on the sophisticated equipment, stringent protocols, and the expertise of embryologists working within these labs. From the moment eggs and sperm are retrieved to the transfer of the embryo back into the uterus, every step is carefully orchestrated within this controlled environment. The IVF laboratory is a place where cutting-edge science meets human compassion, offering a beacon of hope to those yearning to become parents. Stepping inside an IVF lab can feel like entering a futuristic medical facility. The environment is meticulously clean, the air purified, and every surface spotless. This level of sterility is crucial to protect the sensitive gametes and embryos from contamination. A myriad of specialized equipment populates the lab, each piece playing a vital role in the IVF process. Microscopes with high magnification capabilities allow embryologists to examine eggs and embryos in intricate detail. Micro-manipulators controlled by skilled hands enable the delicate procedures of sperm injection and embryo biopsy. Among the most critical pieces of equipment are the incubators and laminar flow hoods. These sophisticated machines provide the controlled environment essential for successful fertilization and embryo development, ensuring that every step of the IVF process is conducted with the utmost precision and care. Incubators are perhaps the most recognizable pieces of equipment in an IVF lab. They serve as highly specialized ovens, meticulously calibrated to mimic the conditions within the female reproductive tract. These controlled environments are essential for the growth and development of embryos outside the body. Temperature, humidity, and gas composition are all precisely regulated within the incubator to create an optimal environment for embryo culture. Temperature is typically maintained at a steady 37 degrees Celsius, similar to body temperature, while humidity levels are carefully controlled to prevent the delicate embryos from drying out. The gas mixture inside the incubator is also crucial. Embryos require a specific balance of oxygen, carbon dioxide, and nitrogen to thrive. Incubators are equipped with sensors and regulators to maintain this delicate balance, ensuring that the embryos have the ideal atmosphere for healthy development. IVF labs utilize various types of incubators, each designed to provide specific conditions for embryo culture. Traditional incubators are large, box-like units that house multiple embryos from different patients. They maintain a stable environment through continuous monitoring and adjustment of temperature, humidity, and gas composition. More recently, time-lapse incubators have gained popularity. These advanced systems incorporate cameras that capture images of the developing embryos at regular intervals. This technology allows embryologists to monitor embryo development without removing them from the incubator, minimizing disturbances and providing valuable insights into their growth patterns. Regardless of the type, all incubators are equipped with sophisticated monitoring systems. These systems constantly track critical parameters, such as temperature, humidity, and gas levels, triggering alarms if any deviations from the set parameters occur. Data loggers record this information continuously, providing a comprehensive record of the conditions within the incubator and ensuring the safety and well-being of the developing embryos. While incubators provide the ideal environment for embryo development, maintaining sterility within the IVF lab is equally crucial. This is where laminar flow hoods come into play. These specialized workstations are designed to create a particle-free and sterile environment, protecting sensitive gametes and embryos from contamination. Laminar flow hoods work by drawing air through a HEPA, or high-efficiency particulate air filter, which removes over 99.97% of airborne particles including bacteria, viruses, and fungi. The filtered air is then blown in a unidirectional laminar flow across the work surface, preventing the entry of any contaminants from the surrounding environment. This controlled airflow creates a sterile barrier between the lab environment and the work area, ensuring that any procedures performed within the hood are carried out in a completely sterile environment. This is crucial during procedures like egg retrieval, sperm preparation, fertilization, and embryo transfer, where even the slightest contamination can have devastating consequences. Section 6. HEPA. Filtration and anti-vibration. Key features of laminar flow hoods. HEPA filtration is undoubtedly the most crucial feature of a laminar flow hood, ensuring the removal of harmful particles from the air. These filters are designed to trap particles as small as 0.3 microns, with an efficiency of 99.97%, effectively removing bacteria, viruses, fungi, and other contaminants that could compromise the integrity of the IVF process. Another important feature of many laminar flow hoods is the incorporation of anti-vibration platforms. These platforms isolate the work surface from any vibrations in the surrounding environment, providing a stable platform for delicate procedures. Even the slightest vibrations can disrupt the precise movements required during micro-manipulation techniques, potentially damaging the sensitive gametes or embryos. The combination of HEPA filtration and anti-vibration platforms creates an ultra-clean and stable environment within the laminar flow hood, ensuring that the delicate procedures involved in IVF are carried out with the highest level of precision and safety. Section 7. Precision and expertise. The human element in the IVF lab. While sophisticated equipment plays a vital role in the IVF lab, the human element is equally crucial. Highly skilled embryologists are the heart and soul of these labs, their expertise and meticulous attention to detail ensuring the success of each IVF cycle. These highly trained professionals are responsible for every step of the process, from retrieving eggs and preparing sperm, to performing intricate micro-manipulation techniques like intracytoplasmic sperm injection or ICSI and embryo biopsy. Their keen eyes, steady hands, and in-depth knowledge of embryology are essential for identifying healthy eggs and embryos, optimizing fertilization rates, and selecting the most viable embryos for transfer. The work of an embryologist demands not only technical expertise, but also compassion and empathy. They understand the emotional roller coaster that couples undergoing IVF experience and provide support and guidance throughout the process. The human touch, combined with cutting-edge technology, is what makes IVF labs places of hope and possibility for couples facing infertility. Section 8. Beyond equipment. The importance of quality control and standardization. The success of an IVF lab depends not only on its equipment and the expertise of its staff, but also on the implementation of rigorous quality control measures and standardized protocols. Every aspect of the lab's operation, from environmental monitoring to equipment maintenance and procedure protocols, must adhere to the highest industry standards. Regular quality control checks ensure that all equipment is functioning correctly and that the lab environment meets the stringent requirements for sterility and environmental control. Standardized protocols for every procedure, from egg retrieval to embryo transfer, minimize variability and ensure that each step is performed consistently and accurately. These measures are crucial for maintaining the integrity of the IVF process, reducing the risk of errors, and ultimately, improving success rates. By adhering to strict quality control and standardization protocols, IVF labs can provide patients with the best possible chance of achieving their dream of parenthood. Section 9. A Future of Hope IVF Labs. Paving the way for successful ART outcomes. IVF laboratories stand at the forefront of reproductive medicine, offering hope and the possibility of parenthood to millions of couples worldwide. These labs are constantly evolving, incorporating the latest technological advancements and refining techniques to improve success rates and expand access to fertility treatment. As technology continues to advance, we can expect to see even more sophisticated equipment and techniques being incorporated into IVF labs. Artificial intelligence and machine learning are already being used to analyze embryo development patterns, potentially leading to more accurate embryo selection and improved implantation rates. The future of IVF is bright, and IVF labs will continue to play a pivotal role in shaping the landscape of reproductive medicine. By combining cutting-edge technology with the expertise of dedicated professionals, IVF labs will continue to pave the way for successful ART outcomes, bringing the joy of parenthood within reach for countless individuals and families.